Hey everyone, let's take a look at number 4 in section 4.7. We're going to find two positive real numbers such that the sum of the first number and the second number is 30 and their product is a maximum. So they want you to use exact values for your answer, and they want you to give your answer as a comma separated list of two values. That just means the two numbers that you wind up with separated by a comma. Okay, so to set this problem up, this is the way you should do it on a test. Similarly, you want to assign some variables, right? Showing your work. Let x be the first number and y be the second number. If p is their product, then we have this. P is equal to xy, and we're trying to maximize p, right? That's the point. Find the two numbers such that the product is a maximum. Well, we just can't pick any two numbers. We do know that they're both positive real numbers. I mean, that's important. But what other information do we know? Well, we know their sum, the sum of the first number and the second number is 30. So that's the constraint, right? And we can write that out as x plus y, that would be the sum, is 30. So now what we can do is we can solve here for y, for instance, by simply subtracting x. And then what we're going to do is take that information and replace y in our function for the product so that I'll have product as a function of x only, and then I can use the calculus to find when that is going to be maximum. Note that again, x is positive, so it's greater than 0. Notice it also has to be less than 30. How do we know that? Well, because if it's 30 or more, then the value of y would not be positive. Does that make sense? Since y is obviously, x plus y has to be equal to 30. Okay, so I'm going to just replace y with 30 minus x. I'm going to distribute the x through, and I'll get 30x minus x squared. So basically, I just want to find the maximum for this function on this open interval. Notice it's an open interval. That's important. Take the derivative of this function to find our critical points. Derivative of 30x is 30. Derivative of x squared is 2x. When is this derivative equal to 0? Well, that's going to be, I hope you can see it, when 2x is equal to 30, right? This difference would then be 0, which means x is 15. So before you assume that this gives rise to a maximum, we need to show a sign check, right? And you should do this on a test. You need to show proof that we have a max. Indeed, we do. So here's my interval. X is varying, remember, from 0 to 30 up here. The sign of my derivative at 15, we just found out it's 0. Plug in a number between 0 and 15, like 1. And you can see clearly if I plug in 1, here's my derivative. If I plug in x as 1, I get 30 minus 2, which is 28 positive. If I plug in something bigger than 15, like 16, 30 minus 2 times 16 is 32, and so the difference would be a -2, negative. So what's happening? First derivative test, we're changing sign from positive to negative at the critical point. That means we have a maximum, right? So we have a maximum at 15. When x is 15, what's the value of y? Well, remember, y is just 30 minus x, and so 30 minus 15 is 15. So our two numbers are 15 and 15. Okay, and so that's true in general. If you have two positive real numbers and you're trying to, and you have a fixed sum, right, for the two numbers, and you're trying to figure out what combination will give you the maximum product, the answer is when they're equal. Okay, so I hope this is helpful on this one. Pretty easy, but again, real important that you show your work clearly like I've done here on the test, labeling variables if you need to, and make sure you indeed show that you have a max or a minimum for your problems.